as we look at Lesson 8.1, it's conic sections and a new look at parabolas. So a new look at parabolas because you guys know the basics about parabolas, but we're going to go a lot more in depth with parabolas. But before we get to that, we're going to talk where these parabolas that we're talking about today. In Lesson 8.2, we'll talk about ellipses. And in Lesson 8.3, we'll talk about hyperbolas. And these are our three main conic sections. So a second degree quadratic equation in two variables is an equation of the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Okay, officially, some of these equations, what we're looking at, if they were in that form, would have all those pieces. And that is assuming that A, B, and C are not all 0 at the same time. Okay. Now, a conic section, or conic as you'll often hear, is the intersection of a plane, so a flat surface, with a set of right circular cones joined at the vertex. So you've got two cones standing nose to nose, okay, or connected at the vertex there. The three conic sections are created when you take a plane and slice through them. It's like in this first one here. You take this plane and you slice at an angle that catches only one of the cones, and a parabola is formed. And I don't know if you guys can see the red line on my screen there, but there's your parabola, formed when it slices through that cone at an angle like that. Okay, that's a parabola. That's what we're going to be talking about as we go through Lesson 8.1. Then Lesson 8.2, we'll talk about an ellipse, or circles, and that happens when your cone, again, or your plane, just crosses through one cone or the other, but it crosses through at a point that it goes all the way through. So slicing through an angle, it makes an ellipse, so like an elongated circle, or it just makes a circle if it cuts through flat, okay? So those red outlines there are your example of ellipses or circles. And then the third option we're going to talk about is if you have a plane that cuts through both cones. And then what you'll notice here, if you can see it, is it makes two outgoing curves. Okay, it makes two curves that go out from each other. And those are what we call hyperbolas. We've actually had a teeny bit of work with hyperbolas already. Excuse me. Do you guys remember the reciprocal function from Lesson 1.3? It was the one where you had the curve in the quadrant 1 and the curve in quadrant 3. That's a hyperbola. Okay, we called it a reciprocal function, but the shape is a hyperbola. Now, the hyperbolas we're going to look at are going to either be horizontal to each other or vertical to each other. But those are hyperbolas. So, and you're seeing two sets of hyperbolas, one with each plane there. But they're two curves going out from each other. So as we move through the chapter, those are the three conic sections we're talking about. So today our focus is going to be on parabolas. I'm going to move this screen up a little bit so I can talk about it better. Okay, parabolas. You've got a little bit of this knowledge, but we've got a lot of new vocabulary here to add in. A parabola is the set of all points in a plane equidistant from a particular line that we're going to call the directrix, and a particular point, which we're going to call the focus, in the plane. So if you look down here at these four examples of parabolas, okay, the parabola being drawn in blue on my screen, its equidistance from the line which is the directrix. So the directrix is this red line that is outside of the parabola. Okay, each of these parabolas has a line that is outside of it. And then the focus is the point that is inside the parabola. So the idea is that you've got this focus and this directrix. All points on the parabola are equidistant between those two pieces. Okay, so any line drawn from the directrix up to the parabola is going to be equidistant from the focus to the parabola. Okay, that's officially the definition of a parabola. Okay, now a little bit of other vocabulary. The line passing through the focus and perpendicular to the directrix is the focal axis of the parabola. So right here, passes through the parabola, perpendicular to the directrix. Well, that's the y-axis in this case. Okay, but that's also the focal axis. Notice, I didn't really point out, did you guys catch? We've got a parabola opening upward here in these pictures. A parabola opening downward, and what else do we get to throw in? Parabolas opening to the right and to the left. So last year in Algebra 2, if you remember me saying our parabolas are only going to go up or down this year, well, now it's next year. And our parabolas can also open left and right. Okay? And so that means the focal axis is going to be the horizontal axis in those two cases. The point where the parabola intersects its axis is the vertex of the parabola. You guys already know the vertex. Okay, that's the vertex that you are used to knowing. The vertex is located midway between the focus and the directrix and is the point of the parabola that is closest to both the focus and the directrix. So the vertex is in the middle of the focus and the directrix. And in fact, you'll notice here it's labeled P and P, showing that those two distances are the same. And that takes us to the next part. The focal length is the distance from the vertex to the focus of the parabola. So vertex to focus, that is the focal length, and it's noted as P. We haven't talked about the chart yet here, but if you notice, focal length is what? Focal length is P. So that's the distance from focus to vertex. More of a geometry review here. A line segment with endpoints on a parabola is a chord of the parabola. So if it goes from one piece of the parabola to another piece. And I bring that up because the focal width is the length of the chord that goes through the focus and is perpendicular to the axis. So I realized after I used these specific diagrams, the focal width is not drawn in here. Your focal width is a chord that goes through the focus from one side of the parabola to the other side of the parabola. That right there is your focal width. It goes clear across your parabola and goes through that focus. Okay, that is your focal width. And as the definition says, it's the length of the chord that goes through the focus and perpendicular to the axis. I don't know if mine's exactly horizontal as it should be, but goes from one edge of the parabola to the next and cuts through the focus in the process. That is your focal width. Okay, so a lot of new vocabulary here. And I will say some of this vocabulary is going to carry over to our ellipsis and hyperbolas. Okay, this is not going to be our last talk of some of these words. Now, I've got two charts for you. We're going to start on this page, and I'm going to talk us through this a little bit, and then we have another chart. This chart is specifically guided towards parabolas with the vertex at 0, 0. So on all of these, the parabola is centered at 0, 0. That's where the vertex is. Now, you'll notice there's two different columns. I tend to refer to them as left column and right column. But one standard equation here in the left column, x squared equals 4py. Or if you ignore the 4p, which is just a constant, do you see y equals x squared? And y equals x squared is the parabola you guys know, right? That's like the parabola that you've been dealing with for years. Y equals x squared. Well, notice what it says. Y equals x squared is going to open either up or down. As opposed to, what about this one over here? Instead of it being y equals x squared, this one is, do you see x equals y squared? So this one switches the square. Okay, you have x equals y squared, and when you switch the square, notice what happens. This parabola is going to open either to the right or the left. So when you put the square on the y instead, we're going to have a parabola that opens to the right or to the left. Okay, now you'll want to use these charts as reference. Okay, if we go back to the parabola that's centered at 0, 0, opening up or down, its focus is at 0p. So that's going to be left to right 0, up p. The directrix, it's a horizontal line. It's y equals negative p because it's that same distance down. The main axis is the y-axis. That's your focal axis. Focal length is always p, distance from focus to vertex. And your focal width is the absolute value of 4p. Okay? A lot of this in the other column is very similar. The other column is going to be for parabolas that open to right or left. So notice your focus is now, instead of 0p, it's p0. So it's going over p, up or down 0. Directrix, x equals negative p. So that's just a vertical line now. Your focal length and focal width are still the same. Okay? Keep this chart handy. You're going to want it. Now, let's look to the next page. And I could figure out a good way to get these on the same page and get examples so the charts end up getting split. But on the next page, notice what's the difference. Instead of parabolas with the vertex at 0, 0, these parabolas are centered at HK. So what that means is these parabolas have been translated. They're no longer at 0, 0. They've been moved over H and up K. Okay, or left to right H and up or down K. So in this page, it's particularly ones with vertex of H comma K. Notice we have a left column and a right column again, yes? I tried to put the pictures with them. In the left column, what do my parabolas do? They open up or down. Do you still notice that it is y equals x squared? Do you still see that? There's y and there's x squared. The minus h and the minus k, that's how far left or right and up or down. Okay, and the 4p is just a constant. Notice my focus, instead of being 0p, it's h and k plus p. Just got to, include the hk vertex. The directrix, instead of being y equals negative p, it's y equals k minus p. Instead of my axis being x equals 0, I moved over h. Notice focal length and focal width did not change. Okay. Similar stuff in the right column. Do you see it? X equals y squared. So that's your general right column. These parabolas open up left or right. Instead of p0, you've got the h and k thrown in here. H minus p instead of just negative p, and k instead of 0. Now, what we're going to spend a lot of our time working on is trying to write equations to match these situations. Okay? If you look down at the bottom of this page, you see 3 examples. Each example is a little different. And our job is to try and write an equation. Okay? We're going to use the clues that they give us in the problem. And we're going to use these charts. Okay? So you're going to want to have this chart handy. And you're going to want to have the chart on the previous page handy of parabolas with a vertex at 0, 0. Okay? I'll try and walk you through it. Ask me questions as we go here. And so let's go to example 1, or 1A, excuse me. Write the equation of the parabola given the following information. Now, it says the directrix is x equals 2. And the focus is at negative 2, 0. Now, what I'm going to tell you guys here, or the hint I'm going to give you, is I see a 0 in this problem. If I see a 0 within my focus, that gives me a clue as to which chart I need to go to. Are we going to use parabolas with vertex 0, 0, or parabolas with vertex hk? And what I would look at here focus is negative 2, 0. Well, on HK, my focuses are H comma K plus P or H plus P comma K. And I will tell you, you can always use this one. It just makes some of your easier problems a little bit more difficult sometimes. But what do you notice about the focuses on this one? The 0P or P0. If there's a 0 in the focus, I would go back over this way. Does that make sense? And I would think about using this chart. Now, and I know it's a pain how I have it set up. Let me just write, I'm just going to write this here so we can see it next to it. What do we know? The directrix is x equals 2. And the focus is negative 2, 0. Yes? Okay. If we're going to use this chart where the vertex is 0, 0, is this a left column problem or a right column problem based on this information here? Why right? Because what?
Because 0 and the negative 2, 0, 0 is in the y.
Okay. So one way to know, this is negative 2, 0. Where's the 0? It matches up right there, doesn't it? What's the other way I can feel confident this is a right column problem? What do you notice about the directrix? It's x equals a number. Which column does that match up with? Is that a right column problem? Okay, so what I'm trying to get you guys to realize is match up some of this information. Okay, based on the format of my focus and the format of my directrix, this is a right column problem. So what's the equation format I'm going to be using? I'm going to take this back to my other page and try and fill it in. Y squared equals 4px. Okay, now I'm going back to my other page so I can start writing stuff out. Now, what did we already decided that the vertex was 0, 0, didn't we? Okay, because we decided we need to use that chart because there was a 0 in the focus. What do I need? I only need one piece of information. X and Y are variables. What's the only piece of information I need to fill in? I need my p-value. Now, what do we know? According to the other page, my directrix form is x equals negative p. The focus was supposed to be p comma 0, yes? Between those two pieces of information, what can you tell me the p-value is? P is what? You got a 50-50 shot at this point. It's either 2 or negative 2. Yeah. Right here, folks. Look at your focus, right? P equals negative 2. Now, if the directrix is confusing you, does that make sense, though? Think about it. X equals negative P. If P is negative 2, what's the negative of negative 2? Positive 2, yes? So right there, the p-value is negative 2. Can you write an equation? Y squared equals 4 times your p-value of negative 2 times x. What is that when you clean it up? Four times negative 2 times x is negative 8x. And we're going to leave it in that form, folks. Y squared equals negative 8x. Now, because I want us to try and make some connections, we didn't draw a picture to do this problem, but I want to sketch a picture here so you can start to understand how this all goes together. My vertex was where? It was at 0, 0, yes? My focus is at -2, 0. And where's the directrix at? The directrix is the line x equals 2. Okay, that's just me writing in the information as provided, or that I figured out. Which way is my parabola going to open? Does my parabola go this way or this way? As in, opens that way? Well, where's the directrix in relation to my parabola? Do I have it? I don't have it on this page. Where's the directrix in relation to the parabola? The directrix is outside of it, yes? Where's the focus in relation to the parabola? It's inside of it, right? So with that in mind, if I want my focus to be inside the parabola and the directrix to be outside, which way is it going? It's going to open left, or at least that's what I would call open left. Okay? And again, I know it didn't say to sketch the parabola. However, we need a lot of help with understanding right now, don't we? I know this is all very new, and I want to help you guys to understand how the pieces connect. Are there questions I can answer right now? I think my morning class was to the point someone said, I just don't know what questions to ask right now. They weren't there yet with questions, but nothing specific I can answer yet. Okay. Now, I don't know if it's a good thing or a bad thing. Every problem is going to be a little bit different. Okay? I mean, it's a good thing in that just because you get stuck on one problem, does that mean you can't do the entire rest of the assignment? No. Okay. We can keep working on it. So let's look at this next one. The vertex is at 3, 4, and the focus is at 5, 4. Now, if you had to guess, is this parabola going to have a vertex at 0, 0, or is this going to have a vertex at HK?
HK.
It's going to have to be HK, isn't it? Because they don't give me zeros, do they? Okay. Now, the other piece that would be helpful to figure out is whether this is going to be left column or right column. And here's where I'm going to say, can we sketch a little bit of a picture? And I'm not saying you have to sketch a picture to get this answer, but I think it is helpful. Sketch a little picture with me. We have a vertex at 3, 4. 1, 2, 3. 1, 2, 3, 4. I'm just going to put V for vertex there, just so I know what that point is. And then what else do I know? I have a focus at 5, 4. And again, I just put an F for focus, just so I know, otherwise it just looks like two random dots. Based on just that information, which way does this parabola open? Do we see it? To the right? Because here's my vertex, right? We know where the vertex of the parabola is. That's the point of the parabola. What we usually say at the bottom of the parabola, right? Where's the focus have to be? It's inside the parabola, yes? If it's inside the parabola, what's this looking like? It's looking something like that, isn't it? Okay. And this is just a sketch, but does it give you the information you need? In my opinion, it does. Okay. So if I go back to my chart, is this going to be a left column or right column problem? So is this left column or right column?
Right column.
And why is it a right column?
Because it's to the right.
My parabola opens to the right or the left, doesn't it? Since my parabola opens to the right or the left, I'm going to use that equation right there. I'm going to go write it on my paper, okay? So we're going to be trying to fill in y minus k squared equals 4p times x minus h. That's my goal. That's what I've got to fill in. Now, how many pieces of information do I have to have here? I'm going to have to know h and k, and what else do we have to know? P. 4 is just a number, right? So we don't have to know anything about 4. And x and y are your variables. They're going to stay. So your x and y are always going to stay. You're always going to be looking for h, k, and p. Well, what do we already know?
H and K would be the vertex.
Yes? You guys with me? If you go back to that paper, it says vertex HK. We were already told the vertex is 3, 4. So what's that mean? H goes in for 3. Or excuse me, 3 goes in for H, and 4 goes in for K. Okay, got an easy part out of the way. Thoughts on how we can figure out the focus, or excuse me, the p-value? And there's a couple different ways we could do this. So if you don't agree with one way, it doesn't mean you're wrong. Go ahead.
P is the difference between the vertex and the focus, so it would be 2.
Okay.
Negative 2.
Wouldn't it just be 2?
It would be, I'm trying to figure out how I want to explain this. It would be positive 2. Okay. Now, were you looking at your points or were you looking at the graph?
The graph.
Okay. So right here, do you guys see that distance there? The definition of P is the distance from vertex to focus, yes? So right there, that is one way, because that distance is 2, that will tell you that P is 2. Now, I will tell you the p-value kind of goes positive or negative along with which way the parabola opens. And I'm going to show you another way to find it here in a moment. But go back to your basic parabola that opens up or down. What do we know? When it opens up, it's positive. When it opens down, it is negative, yes? Right and left has the same situation. When it opens to the right, that is your positive values. When it opens to the left, that is your negative values. Here's my other proof. Okay, if you're saying, I didn't like my picture, or I didn't really look at my picture. Okay, we were given the focus, yes? If you go back to the chart, what's it say the focus is defined as? H plus P comma K, right? This is how I'm going to say that you could also find it. H plus P comma K. What do we already know the focus is? 5, 4. Do you see the connection there? What do we know right here? We already know K is 4, right? And I know right here that H plus P is equal to 5. But what do we already know about H? H is 3. So then I know that 3 plus P is 5. We'll do the math. If 3 plus P is 5, what's P? P is 2. So there, if you like looking at the graph, I'm fine with looking at the graph and saying, oh, hey, I see the difference is 2. I got 2. That's fine. The other option, if you're like, yeah, I didn't like looking at the graph, could you just look at the algebra behind it? You can. Okay? So, for that reason, I'm going to argue that P is 2. And it opens right, so P should be positive. Or it should be a positive value there. Okay, can you write your equation? We're not going to multiply it out or anything other than multiplying 4 times P. So, y minus 4 squared equals 4P, so 4 times 2, which is 8, times x minus 3. And you're just going to leave your forms like that, folks. Okay, you won't usually go anywhere past that. Okay, questions I can answer there? Thought maybe Ethan was going to give me a question. Okay. Okay, let's try one more then. As I said, I don't know if it's pros or cons, you know. Every little problem is different. So that means some of them will be good for you, some of them won't be so good. So, okay, this final parabola on this page opens left. The vertex is negative 3, 2, and the focal length is 2.
Don't we have everything we need?
Yeah, you just have to be able to put it all together. Okay. I am going to do a quick sketch, although, as Aiden said, don't we have everything we need? Well, yeah, we kind of do. So do you have to do this sketch? No. I'm just trying to get you to put all the pieces together, okay? So what do we know? The vertex is at negative 3, 2. The focal length is 2, and it opens left. So what information can you specifically tell me? I guess officially I could draw. It opens left, yes?
The focal point be negative 5, 2.
It would be. And officially, some people are going to argue we don't have to know that. I understand. However, it's all about connections here. Do you guys see that? Why would it be at negative 5?
Because the focal length is 2.
Yeah, the focal length is 2. If you go back and look at that very first page, it will tell you the focal length is the distance between the vertex and focus. Okay?
Is that 2 actually going to be negative 2?
It is. Okay, so the focal length is 2 tells me the length of P is 2, but then you still have to decide positive or negative. And so because the focal length equaled 2, I'm going to say that P is negative 2, and it's negative 2 because why? Because opens left. So if you want to write yourself a note here, negative because it opens left. Okay, so there's your P value. I always need 3 things, P, H, and K. Do we have H and K? Yeah, that is my vertex, yes? So h is -3, k is 2. Which equation am I using? Okay, it's that right one on the HK chart. So y minus k quantity squared equals 4p times x minus h. Okay, that's the equation you're filling in if you haven't already. Y minus what? Y minus 2 quantity squared. 4p? What's 4p going to be? -8 times x minus -3, which does become x plus 3. Okay. So here's what I'm going to tell you. Obviously, we're at a stopping point on notes here. We do have one more page of the notes to do. Okay? That makes your homework due on Friday. Now, here's my suggestion. Okay? The other page of this notes talks, we're going to spend some time tomorrow talking about how to graph these parabolas on a calculator, which in order to type something into your calculator, it has to be in that y equals form. So we're going to kind of go away from what we're doing here today. My recommendation, okay, so 7 through 10 is a matching bit. Should be pretty easy based on what we've gone through today. 12 through 30 evens are like these three problems here. I would encourage you to go ahead and look at that sooner rather than later, just because this is going to be more in your head right now. Okay? 40, 42, and 46 are going to go with what I'm going to teach tomorrow. So if you have time, I would encourage you to go ahead and look at 12 through 30, even though it's not due till Friday. I know some of you won't, and that's fine. You're going to have more success, I think, if you look at it sooner while it's fresher in your head. My opinion. Okay? So we'll come back, finish notes tomorrow. Homework will be due Friday.